Okay, let's take a look now at a proof of the derivative rules for sums and differences. And actually what I'm going to do is I'm going to do the proof for sums, and you're going to see that the difference is going to follow pretty logically from that. So let's let h of x. I'm going to let h of x be a sum of two functions, f of x plus g of x. And what I want to find is I want to find the derivative of h. I want to find h prime of x. Well, I know using my limit definition of the derivative that h prime of x is equal to the limit as h approaches 0 of, I can go ahead and write it out as h of x plus h minus h of x all over h. And just kind of a note here from a notation, this is the function h up here in the numerator, and then it's the value h that we've been using to represent our change in x down here in the denominator. So not the same h's right here. And in fact, I'm going to go ahead and clear that up because h of x plus h means plug x plus h into the x's here. So if I now get this in terms of f and g, h of x plus h is f of x plus h plus g of x plus h. I'm going to go ahead and use some grouping here so that you can see that's h of x plus h minus h of x, which was simply f of x plus g of x. F of x plus g of x. And this is, of course, all over h. So let's go ahead and take this negative sign and distribute it in to f of x and g of x. So I can now say this is the limit as h approaches 0 of f of x plus h plus g of x plus h minus f of x minus g of x all over h. And now if I do some grouping here in the numerator, so I've got f and I've got f, I've got g and g. Let's kind of group them together so that we can see what's going to happen. So I have the limit as h approaches 0 of f of x plus h minus f of x plus g of x plus h minus g of x all over h. And I'm going to go ahead and do a couple of steps here in one. Anytime we have a single term in the denominator, a monomial, I can take that fraction, I can split it up into its individual components. So I can take this part here with f, and I can put it over h, and then I can add the part with g and have it over h. And I can do that because there's a single term in the denominator. I also know with limits that when I do that step, I'm going to take this fraction, I'm going to split it up as a sum, that I can take the limit of that sum as the sum of the limits. And so what I'm going to do, and I'll explain it again as this gets written down, this is going to equal the limit as h approaches 0 of, I'm going to focus on these two pieces over h, f of x plus h minus f of x all over h, plus the limit as h approaches 0. And now I'm going to look at the parts involving g. I'm going to say that's g of x plus h minus g of x all over h. And if I take a look at what I've got here, this right here, that's the derivative of f by its definition. That is f prime of x. And this guy right here, that's g prime of x. So I've got f prime of x plus g prime of x. And so what I can say now, if you go back and look at what I was trying to do, I was trying to take the derivative of the sum of f and g, and what I ended up with was the sum of the derivatives. So I can say as a rule, the derivative of f of x plus g of x is equal to f prime of x plus g prime of x. And I will tell you, if I did this same proof, but instead of f of x plus g of x, I did f of x minus g of x, a lot of my signs would be alternating here, but I would end up in the same place, except I would have a minus sign in front of them. And so what I can actually say is I can take this rule here for a sum. It also is going to apply for the differences of functions. And so generally, what I can say, if I'm taking the derivative of a sum, the derivative, a sum or difference, I should say, f of x plus or minus g of x. The derivative of this, and this is going to be really nice when we start talking about polynomials. What it equals is it is f prime of x plus or minus g prime of x. What it's going to allow us to do is if I wanted to take the derivative of, let's say, 3x cubed plus 9x squared, I can take the derivative of each individual piece. I can take the derivative of 3x cubed, I can take the derivative of 9x squared, and I can add them. And we learned how to do that in the previous video. And so what we're going to do next is we now have a really good collection of derivative rules between the power rule from 2.5 and then how to take the derivatives of constants, coefficients, and sums and differences. In the next video, we'll go ahead and look at how that works in terms of taking the derivative of a polynomial in general.